We concluded the previous video by understanding the first law of chemical combination. Now we need to take a look at the second law, which is called the law of constant proportions or the law of definite proportions. They're the same thing. The law was first put forth in the year 1797 by a French chemist called Joseph Proust and hence is also referred to as the Proust's law. What does the law state? The law states that in a chemical substance, elements are always in a fixed proportion by mass. Now what does this mean? It's not straightforward to comprehend this statement at the first glance. Remember the example of chocolate milk that we considered while studying the first law? In that example, we saw that when we have to make double or triple the amount of chocolate milk, all we have to do is use the proportionate amount of the individual ingredients. Wait, did I say proportionate amount? What does that mean? It means that when we have to make the drink for 10 people instead of 5, we just have to take double the amount of ingredients, right? Anything more or less would result in change of taste. Similarly, in any chemical substance, the elements present are always in a fixed proportion by mass. So let us take the example of elements A and B giving us the compound C. Now, if we observe just one single unit of the compound C, then we can notice that it has 2 atoms of element A and 3 atoms of element B. Is it true for all the units making up the compound C? Yes, it means that even if one atom from any of these units is removed or added, then it can no longer be called compound C. It will change to something different. So if the number of atoms is fixed, then the mass will also be constant, right? Absolutely. The best example to study this is that of ammonia. If we decompose ammonia by any means, say by extreme heat or some other way, then we get the nitrogen and hydrogen atoms in the same proportions by mass. So let's say we take 17 grams of ammonia. If we decompose it, then we will get 14 grams of nitrogen and 3 grams of hydrogen. So can we say nitrogen and hydrogen are present in ammonia in a constant ratio of 14:3? Even if we decompose ammonia in any other way, the ratio of nitrogen to hydrogen in the compound will always be the same, 14:3. Yes, and this is seen in all the compounds existing naturally or even artificially. But when these laws were put forth in the form of theories, proving them was quite a concern. All these explanations that we know now are due to experiments performed for many decades. Several scientists came up with many experiments and explanations. Among all, a notable theory by the name Dalton's atomic theory surfaced as an answer to many of these questions. The theory was put forth by the English chemist and physicist John Dalton. Watch the next video to understand what Dalton had to say about this theory.